Okay, now my question. You got the weight 245 kilonewton. Why the force exerted on it is only 196? Why? The shape? Open? Distribute? You are almost correct. I think you got the idea. You know why? Slanted surface. So?
Open tank.
Open tank. If it is closed, then it will give you the same. The force is working. Not all reach. Where it goes? Just like you're supposed to go to the class. Some of you goes to the canteen. Some of you goes to the cinema. Then only small part of you will come to here. These three distributed. See? Some of it will give force to that. Some will give force to that. How do you calculate that? How do you calculate the force working on the slanted wall? Cos that side? Sure? Okay. Just now I told you, right? This is the part that I hate the most during my undergraduate. When I learned about this horizontal plate, oh, I love it. Okay, gamma times h times e, that's it. You need to do it easily. How about that? How do you calculate? This door keep open. Close it just now, right? If it open again, next week I do not want to stay here. How do you calculate on the slanted area? Any idea? Cos and sine, you say, right? Any other idea? Do you read the slide before you came to the class? No. Okay, next time you need to do. For those, I give you a quiz before we start the class. How? Give me a very good introduction to the force working on the slanted surface. So you can see that the force is not the total force, right? Some of this force will go on this and that. Now the question is how to calculate that. That is this. Okay, the derivation, read it on your own. I do not want to scare you, right? Enough people hate me. All my students hate me because I show them the derivation of Navier-Stokes, so I do not want to do the same. You see, this is how we got it. You need to have the centroid, CP. Sorry, centroid. CP is the so-called center of pressure. This is the point where the pressure force is working, not the pressure. This is the point where the pressure force. Remember the difference? Pressure force. Different. Pressure is pressure, scalar. Pressure force is force. Has a direction. So this is the location where the resultant force due to pressure is working. Okay? So how do you calculate that is, you know, the force acting on the small area is, what's this? What is gamma H? What is gamma H? Class, what is gamma H? Pressure. Pressure times area. Why dA? Because we are talking about small part here, small area here. dA, small dA. Okay, so dF, because dF is also fraction of the force. is equal to gamma H dA. So if you have dF and dA, how do you get F? Integrate it. You integrate it. Integrate over the area, the total area. Okay? Gamma H dA. Is that clear until this point? Okay. Then if you look at the H, you see that H? H is equal to Y sin theta. Right? Y sin. You are correct. Using sine and cosine. Orientation. Now the problem is, from this, how you solve it? Any idea how to solve those? Anyone didn't pass calculus? All of you passed the calculus, right? Anyone didn't pass the ODE? No? Okay, so you know how to integrate this. Can you please integrate? How to integrate that thing? Okay, it will be very difficult. You know why it is difficult? Because this is a function of the depth. Right? You see dA is moving from here to there. So when you change the depth, when you change the y, this one change. If gamma is function of the depth, you remember just when I told you that the density of seawater deep there is higher than on top. So it is a function of y also. So if it is the case, then you have this one is function of y. This one, of course, is a function of y. This one is function of y. Maybe not. Sin theta can be taken out. You can put it there. dA. dA is equal to. So you will have double integration, right? Yeah. dA is two directions. Remember that. It is not one direction. Two directions. So if you want to solve this one, yeah, you can. But it will be a bit tough. Okay, for our class, we take the assumption, okay, for our convenience, we take the assumption that gamma and theta is constant. Okay, so by doing so, you can take the gamma out from the integration and theta out of the integration. You will end up having this. And this one is the so-called first moment of the area. How do you learn this? Statistics, don't ask me. Okay, you pass your static, right? Anyone retake the static now? I mean now. No, right? So you should know that. Okay, so the first moment of area is defined as YC times A. So what is YC? What is YC? YC is the centroid. It's the direction from point back to the centroid. So that one is called YC. You see this one? So YC is equal to HC sine theta, if it is lengthened like that. Okay. YC is equal to HCR. Okay, so this is how you finally got it. The force working on the slanted plane is equal to gamma times HC times the area. As simple as that. Okay, any question until this part? Okay, don't worry about YC sin theta. This one is because you have slanted, and sometimes you know why it's like this, because it's measured from the surface. But if you know the HC directly, you know the HC directly, you just go directly into HC. Okay? And most of the application, you will not get a slanted surface like this. You may get that. Okay? Vertical wall. Yes?
So will there be questions where they give YC without data?
YC without theta cannot do calculation. If that is the case, okay, and your lecture is not there to help you, I mean to give you what is the theta, you just assume it, then it should be okay. Okay, so in the test, in the exam, if somehow I forget to give the theta and I'm not there in the hall, don't get, oh, okay, this is wrong question, so I should not answer. No, you just put whatever assumption that you think right, then you can proceed with it. Don't worry about it. Right? Because at the end of the day, you see the CLO is not for you to answer, right? It is for you to analyze it. How to analyze and how to, what is your skill? Conduct investigation. Okay, yeah. Me too. So don't worry. Me also forget. Anyhow, so you just worry about HC. Okay, so YC sin theta is nothing but your HC. HC is the head of the centroid from the surface, the depth of the centroid from the surface. Okay, let's say you have water on this, right? And the centroid of this is of course in the middle. So HC is from that to that. Okay, you should not worry about that. The thing to worry is where is the location. Okay, where is the location of it? For the horizontal plate, you know that the FR is working exactly on the centroid of the body, right? So if you have a bucket of water, you know that the force will be working at the middle, at the center of it. But now, what happened to that? On the side. Is it working like that? Then? Where? Where is the location? Okay? That is the problem. So, we need to find the so-called CP. Okay? And CP, so CP is determined by YR and XR. So usually when you have this, you will know your X resultant. So CP is XR, YR. You know where is it? Okay, how to calculate that? YR is defined as IXC over YCA. YC, you remember? The location of the centroid. A, area. YCA. Now the problem is what is IXC? IXC is the second moment of area. What is it? You learned in your statics, so you should know by now. Okay? And for a common shape, this is the IXC and IYC. If you ask me, do I need to remember this? No. If it is needed, it will be given to you. Okay? But which one you use, it's up to you. Right? We will give you all of these. We will give you the shape of that particular surface. Which one is the correct one? You choose. Okay? So you have to select which one is correct. So for a square, it's given there. Right? Be careful with the BA square. B in this case is the base. And A is the head. Okay, don't get confused. Because in the question it may be given differently. A is the base, B is the head. But you know that the equation is this. B is for the base. Because it gives you totally different story there. See, IXC, the one that you're supposed to use, right? IXC or what? Is BA to the power of 3. Okay, if you misplace it with AB to the power of 3, rather than having IXC, you will get IYC. So very careful when you define your second moment of area. Is that clear?